Okay, now in this video, we're going to get into finding the domain and range of a quadratic. And what I want you to keep in mind is, if we think back of when we talked about domain and range for the first time in section, I think it was 3.1 and 3.2 when we introduced functions, we wanted to consider two restrictions. When I'm looking for a domain, I have to be careful about what I'm plugging in for x. If I have any roots in the equation, I want to make sure I'm plugging in values of x so that I don't get negatives under even roots. And then the other restriction was I don't want to plug in values of x where I'm going to get 0 in the denominator. If you look at the equation of either standard form or if you look at it in general form, I don't have any of those issues here. I can plug in anything I want for x. I don't have even roots to worry about negative numbers, and I don't have x's in the denominator where I'm worried about getting a 0 in the denominator. So with the domain of quadratics, it's always going to be all real numbers. I have no restrictions on what I can plug in. So quadratics always have domain all real numbers. If you want to write it in interval notation, it would be minus infinity to positive infinity. Now the range, however, is going to change depending on two things. It depends on where the vertex is at, and it also depends on whether it's concave up or concave down. If I look at a picture that's concave up, and I look at my vertex, remember the range are all the values of y. So it's going to be from my lowest point to my highest point. And in this case, my lowest point would be my vertex, and my highest point would be infinity, right? It keeps going up forever. So this is why it really depends on the vertex and which way it's facing. Because now if I look at it, the other possibility, if it's facing down, I'm going to have no minimum in this case. It's going to go down forever. I'm going to have a maximum value, but no minimum value. So you have to be aware of what your vertex is and which way your graph is facing, whether it's concave up or concave down. So when I look at this problem here, I can see that my h and my k, my vertex is going to be at -2, -2. And I know that this is going to be concave down because I have a negative in front here for my A. If my A is negative, it's facing down. If my A is positive, it's facing up. So this point right here is -2, -2, which means my maximum value for y is going to be at -2. And my lowest point, I have none. So it's going to go all the way to minus infinity. So my range is going to be from minus infinity up to -2. Now that is including -2 because that point there exists. It's not an open circle. There's an actual point there. So for this problem, my range is minus infinity to -2. And because it's a quadratic, automatically I know that my domain is going to be all real numbers. Now in the next problem here, it says determine the domain and range of the following quadratic function and put it in interval notation. So just like we did in the previous example, we have to identify which way the quadratic is facing, and we have to identify what my vertex is. Right off the bat, without even thinking about it, I know this is a quadratic, so I can write down right away my domain is all real numbers. But I have to do a little bit of work so I can see or I can determine what my range is. So in order to figure out what my range is, I need to determine which way it's facing. And because my A here is positive, my A is 2, I know it's going to be facing up. So I know I'm going to have a minimum value for y, and then it's going to go up forever. But the problem is I need to know what that point is, that hk. And remember, I can find my vertex by using my vertex formula, which is h is equal to minus b over 2a. So if I plug in my value for b, in this case my value of b is 4. So I have negative 4 over 2 times a, which is 2. I have negative 4 over 4, which is a negative 1. So I know my h-coordinate for my vertex is going to be 1. But now I have to plug back in my value of 1 back in here to see what my corresponding y value is. So if I plug in 1, that's going to give me 2 times 1 squared, which is 1 times 2. And then I'm going to add it to 4 times 1, which is 4. And then add 6. So I know my k value is going to be 12. So to find my range, I know my minimum value is going to be 12, and it's going to go up forever. And there's a point there. There's an actual point. It's not an open circle. It's not undefined. There's a point there. So I'm going to include 12, and it's going to go up to positive infinity. In the next example, it says use the vertex of the graph of the quadratic function and the direction that the graph opens to find the domain and range of the function. Because this is a quadratic function, I know that my domain, without even thinking about it, my domain is going to be all real numbers. My range, however, I have to do a little bit of thinking. Since it opens down, and my vertex is negative 3, negative 7, I know that I'm going to have a maximum value of y. It's going to go down forever. So it's going to go from minus infinity up to a maximum number. And that maximum number, where it stops, would be at negative 7. Last example, this is telling me it's a quadratic function. And the vertex is negative 3, negative 7. But this time it opens up. So it's very similar to the problem above, but it's going to open up this time. Since it's a quadratic function, without even thinking about it, I know my domain is going to be all real numbers. My range is going to depend on the fact that my vertex is negative 3, negative 7, and it's going to go up forever because it opens up. So this time I'm going to have a minimum value, which is going to be at negative 7. And it's going to go all the way up to positive infinity. It's not going to stop. And so my range is going to be negative 7, including negative 7, up to infinity.